Hello, welcome. This video is the third video in the Cloud Native Ninja series. In the first part, we looked at what are cloud native applications and what are some of the key characteristics of cloud native applications and why are they so popular nowadays. In the previous video, we looked at how to get started with containers, and we specifically looked at having a RabbitMQ broker created on our laptop or developer workstation without having to install RabbitMQ software by using Docker. This is the third video of this series. My name is Nilesh, and we are going to see how to interact with RabbitMQ using something called as Dapr. So let's get started. In the previous video, I explained what is the application we are going to build using polyglot programming with C#, Java, Go, and Rust programming languages with a front end which will talk to a TechTalks producer and API, and we will also have a consumer, TechTalks consumer, which will be decoupled using RabbitMQ as the message broker. Now, if I were to develop this application, let's say 3 or 4 years back, I'm going to start with .NET as the first programming language because I am most comfortable with .NET. But as we evolve in this series, you will also see me explaining things about Java, Go, and Rust. So starting with .NET, let's say if I were to create the APIs for publishing to RabbitMQ using .NET Core and also a consumer, this is how I would have written initially. So I have a piece of code which is called as the TechTalks publisher, which takes the queue name and the routing key along with the RabbitMQ host name, the user and password, the credentials for connecting to the queue. And then I have this code which connects to the queue using the connection factory, which is provided by the RabbitMQ client for .NET Core. Then we also have things around creating a connection. Then we go through the channel, we create a queue, then we set the properties on the queue. And then finally, this is where we actually publish the message to the queue. We use the serialization to serialize the message content. And then the basic publish is what is publishing the message to the queue. On the consumer side, we have the reverse of that happening with almost the same properties or same attributes, except for one change, which is the batch size, where I want to limit the number of messages that get processed in a batch. And I'm defining a property called as RabbitMQ batch size, which I use here. So the process to consume is almost the same. We start with the connection factory, we create a channel, we define the properties again, and then we have the consumer part, where we write event handler when the message is received, and then we deserialize that message which was published onto the queue, and then we write the detail with a small delay to show that this is a process which takes a bit of time, or to show there is a workload running here. So this is what we do with a language specific RabbitMQ client, which is for .NET. Now the problem with this is, for every programming language that we use and we want to interact with RabbitMQ, we will have to use the language specific clients, let's say for Java, for Go, and for Rust or any other programming language. Instead of doing that, what I thought of doing is to use a modern day framework or modern day open source tool, which is called as Dapr. Dapr is what they call as a portable event-driven runtime. It's a distributed application runtime. Microservices by their nature are distributed, and they have a lot of things like resiliency. They have retries, which are not part of the initial, or I would say the legacy application style of development. That is where we need some framework which can cater to the needs of the microservices developers. They also need to have resiliency, they need to have tracing, they need to have distributed tracing in place in order to identify if there are any problems. So Dapr provides all those building blocks and services for an application, and it can be used for building stateful as well as stateless application. These can also be deployed to things like the edge devices or cloud, and they support multiple frameworks and services. So in terms of the code, or in terms of the programming languages, Dapr supports Go, Node, Python, .NET, Java, C++, PHP, and Rust. In fact, anything that can have an HTTP API or gRPC API, if it exposes, Dapr can interact with this. It has modules or components related to service invocation. It has things like security, which can enable us to build a secure communication between services using Dapr as a component. It also provides things for managing the state, where we have long running processes and we need stateful applications. It can interact with the backend state machines. We also have a PubSub mechanism where we can use things like RabbitMQ, Kafka for publishing messages and decoupling the applications from publishers and subscribers using PubSub. When it comes to the serverless, there is support for binding in terms of the triggers and binding resources. So if you have worked with things like Lambda or Azure Functions, they support the bindings and they support triggers based on events. That kind of programming model is also supported by Dapr. And when it comes to cross-cutting concerns like observability, configuration, secret management, Dapr has support for that as well. And it can be deployed anywhere. It can run on physical machines, it can run on virtual machines, it can run on Kubernetes, and it can also run in the public cloud environments like AWS, Azure, Google, and Alibaba. So we can see that Dapr covers a whole lot of things. How do we get started with Dapr? So that is where I would go into the terminal and show some of the things. If you want to start, first thing that we need is the Dapr CLI. And if you've watched any of my earlier videos, you know that I am a big fan of Chocolatey, which is the package manager for Windows. So I can install Dapr. There is a package available on Chocolatey using choco install Dapr. I've already installed it in the interest of time, but that is how you can start with installing the Dapr CLI. There is also a package for Winget. So if you're using Winget as your package manager, you can get the package, or you can download the installer from the Dapr website. Once you have Dapr, the CLI, the next thing to do is initialize Dapr. We run Dapr Init command to initialize Dapr in standalone mode. This also I have done because it takes some amount of time to download the required things for running Dapr. And when the Dapr initialization happens, these are the things which it does. It pulls some Docker images for Redis, for Zipkin, and for placement. And in Docker desktop, we can see that all these three are running. So that is like a prerequisite which Dapr sets up for us to run our application. How do we use Dapr in our application? I'm going to use the Dapr SDK, which is available for .NET or .NET Core. So let me close this older version of the code and show you how we can do things using the minimal APIs, which is one of the new feature in .NET, which allows us to build microservices and APIs instead of going through too much of code. We can have just one program.cs file and we can write our the mappings for that, like the get, post kind of HTTP verbs we can use, and we can set up our API calls. So we start by using the familiar builder pattern to use web application builder. Initial 2 or 3 lines are similar. I don't change anything here. The first thing that we do is in the add controllers method for the services, we use add Dapr. By doing this, it allows us to use those Dapr components and the facilities provided by Dapr in our application. The next thing we do is this line here, which says app.use cloud events. Now cloud events is like a standard. When we are talking about event-driven architecture, event-driven processing, different vendors and different companies or different frameworks, they have different ways of dealing with events. Cloud events tries to standardize this and provide a consistent interface for all the participating people to have a standard mechanism for handling events. And that is what Dapr uses internally. So we enable the cloud events, which allows us to wrap our messages into cloud event format. So when we send and receive messages, those would be treated as cloud events. With that, we use the generate method, or we expose an endpoint as a get endpoint, HTTP REST API this is. So we are exposing a get method, which is named as generate, which takes the number of talks as an input parameter. And then we use a TechTalks generator, which is a helper utility to generate TechTalks in the data model that we have. Then we use the PubSub name and topic name. So PubSub name is the name of the component which we set up for communicating with the RabbitMQ, and the topic that we want to publish our messages to is TechTalks. And finally, we use the Dapr client to build a client. Dapr client builder.build method helps us to create a client for Dapr. All that we do is we call this client.publish event async method with the PubSub name and the topic name, and talk is the actual workload. So we just loop over all the dummy TechTalks which we created, and we publish those TechTalks using the async method. So let's look at how does this PubSub looks like, the configuration. So in my folder structure, I have a components folder where I define all the components, and PubSub is one of the component in that. And later on in the series, we will also see other components coming into the picture. So the definition of PubSub component, it is of the type component. We have some metadata, which is the name of the RabbitMQ PubSub, or we specify name as the RabbitMQ PubSub. And this has to exactly match what we specify here in the PubSub name. As long as the name is same, we can swap this with the compatible PubSub components, which we will see later. What are the different PubSub components which are supported by Dapr? And then specifically to connect to the RabbitMQ, we have the spec which contains the type, which says under the PubSub, we are using RabbitMQ as the PubSub mechanism, and the metadata related to RabbitMQ, like the connection string which we use, whether we want the queues to be durable, whether we want to automatically acknowledge the message. We also set the prefetch count in order to pick the specified number of messages in one batch, and other attributes or metadata related to connecting to the RabbitMQ. So if we go back to our API, we see that the actual code which is required for connecting to RabbitMQ and using Dapr is just this add Dapr method, use cloud events, and then the name of the PubSub and the topic and the Dapr client which we build, and this one single method call to publish the event. We don't have any code which is related to the boilerplate code that we saw earlier for creating the connection, for setting up those properties. All that is now part of a declarative YAML file which we can use to modify, or which we can use to configure the RabbitMQ. So with that, let's go and quickly build this. In order to build, I'm going to use the .NET CLI, and we use the normal commands like .NET restore to restore all the packages which are required for building our producer application. We also have things like .NET build, which will be used to build the application, and we can use .NET run to run the application. So we have successfully built. It has a dependency on the TechTalks model. That is why we see TechTalks model.dll is also being built. It is referenced as a project reference in this project. And finally, we will use the .NET run command to run the application, or to run the producer. So we can see here that it's writing some info messages to say that on the localhost 5027, we have the producer running. So if I click on this URL, we would be redirected to 5027. And if we hit the test method that we have, and we say name is equal to Nilesh, for example, we will have this. Okay, what we could do is we have the Swagger API. We can in fact use that to test. We have a Swagger endpoint expose. So in the test, we can do tryout, and name is equal to, let's say, Nilesh. And if I execute, the method has executed and we had 200 success. So in the logs, we can see hello Nilesh. So that is what this shows, that this application, the producer, is running fine. We will come back to the consumer and we will see how to use that correctly. So I'll stop this for now. That is how we run the normal .NET Core application. So to stop, I have to press Ctrl C here, and that will stop the running application. Let's go and look at the consumer side of things before we start running the application. So the consumer is similar to the producer that we saw earlier. It's also a .NET Core minimal API, and we again have add Dapr to the controllers here so that we have the Dapr capabilities available to our application. The additional thing that we do in case of the consumer, along with using the use cloud events, is to subscribe to the events, and that is done using map subscribe handler. Once we have the map subscribe handler, we can use Dapr's capabilities to subscribe to the events which are published. And the way we do that is using the method which is called as process. We are going to get the contents of the message in the body of the message or the call of the API, and then we just put it for a few milliseconds for sleep to show the simulation process, and then we log the contents of the TechTalk. The thing to note here is we specify in a fluent manner that this has to use a topic, which is again the RabbitMQ PubSub, the one that we configured using that YAML file, and TechTalks is the queue name. And we also specify that this will be exposed in the OpenAPI standard, which will have a Swagger page for that. So with that, let's go and again check the consumer part. So if I do pwd or present working directory, we can see that I am in the src folder .NET under the consumer. We can do the same thing, .NET restore, .NET build, and .NET run. If we directly run the .NET run command, it will do the build for us. So once again, if I can spell it correctly, .NET run is the command that we want to run here. So you can see that it's building, and once the build is successful, it will be running on localhost 6000. That's the port. Now, if we run both the producer and consumer in the normal way, we should be able to communicate. Let's clear this and say .NET run for the producer. And it was exposed, the producer was exposed on port 5027. So if we go back and we generate those number of messages or number of talks, let's say try it out, and let's say I want 100 messages. Let's click on execute and see what happens. So on the producer side, we can see that we were able to publish 100 messages to the message queue. And then if we go on the consumer side, nothing happens. The consumer is still waiting for the messages to be processed. If we go and look at the RabbitMQ UI, which we were looking in the previous video, we can see under the exchanges, there is nothing. Under the queues, also we don't have the queue. Now the reason for this is not a normal .NET application. We have Dapr, which needs to have that sidecar running in order for the application to use Dapr correctly. And we can't use normal .NET run commands. We have to use a slightly different version of that. So let's start with the consumer first and see what change we have to do to the consumer. I'm going to run a command here, which is not the normal .NET run, but we are going to use Dapr run. And in that, we specify the ID of the application, which is consumer. We specify the path to the components because we are configuring some component, a PubSub component for RabbitMQ, and the definition of that YAML file resides in this components folder. We also specify a port for the application, and then we use the .NET run command. So when we do this, before the application starts, Dapr starts a sidecar process, or it runs certain things which are required for the application, like the metric server. It starts it on 61869 port. It also identifies that it is running in the standalone mode, and it starts the trace sampler for collecting the traces. And then we see the actual application logs coming in, which are generated by that .NET run command, which also runs along with the Dapr run. And we see all the other things that Dapr logs, but then we also start with the application logs or the normal application. And here we can see that it identifies that there is a PubSub component named RabbitMQ. It subscribes to the topic or queue. It says TechTalks and consumer TechTalks. So if I go into the RabbitMQ UI, now we can see consumer TechTalks is the queue which is created, and under the exchange there is a TechTalks exchange created. So in terms of the mapping, when we define the queue in RabbitMQ configuration or PubSub, the way Dapr maps it is whatever is the queue name, it gets mapped to an exchange, and the actual queue is the name of the consumer app or name of the app. So if you look back at the command that I ran, the app ID that I specified at the time of running Dapr run was consumer. So it uses this app ID along with the queue name, which was TechTalks, to create the actual queue. Now we don't have any messages published yet, so we have to publish it using the Dapr run command for the producer. So I will switch back to the terminal again, go into the producer, and we will use Dapr run command here. This time we specify the app ID as producer, we specify the path to the components folder, and then we use the .NET run command. So like we saw in case of the consumer, Dapr first creates those sidecar related components and then it runs the actual application. So now if we go back to the Swagger UI and we generate, let's say, 1000 talks, and we execute this, what we should see is the 1000 tech talks have been published, and on the consumer side we see the consumer is able to consume those. And in the RabbitMQ UI, again, if we go into the details of the queue, we can see all those messages here. There was a spike which shows that 1000 messages were created or published to this queue. 50 messages got picked up because we have one consumer, and the batch size, prefetch size that we have specified is 50. That is why those 50 messages, they get consumed, or every time once the 50 messages are consumed, the next batch of messages would contain next set of 50 messages. That is how we make this like a scalable application, which we will see in the later parts of the series, why we do it that way. So with that, we saw that Dapr is able to communicate to the RabbitMQ using the Dapr component. So let's switch back to the slides and see what did we do. In order to set up the Dapr local dev environment, as I said, we need to start with Dapr Init, and once the Dapr is initialized, it will have these 3 Docker images pulled: the Dapr placement, Zipkin, and Redis, which we can again verify by going into the Docker desktop. We have Dapr Redis, Dapr Zipkin, and Dapr placement created and started the containers of that. Then we have our own application. So in our case, we had the producer and we had the consumer. Both of them, instead of using the normal run command, we have to run the Dapr run command in order to provide the component information and the other variables which might be required, like the sidecar process requires. If you are using any environment variables and things like that, all that has to be done as part of the Dapr run command. And that is how Dapr is able to be like a bridge between our producer and consumer when they want to talk to any of the components. In our case, we use the PubSub component for RabbitMQ, but there are other components which we will see later in the subsequent parts of this series. We will be using some other components as we go along. So in terms of the components which Dapr supports, there are various ones, like 100 components as of this date are available under state stores. We have common states like AWS DynamoDB, Azure Cosmos DB, Firebase, Redis, Cassandra. In terms of the PubSubs, we have the common PubSub brokers like RabbitMQ, Redis, Azure Service Bus, AWS SQS, and we can look at all the other types as well. But the whole point here is Dapr is that one distributed runtime which we can use to communicate with all these different 100 components, and it allows us to swap that. So let's say tomorrow instead of RabbitMQ, I want to use Redis as my PubSub component. All that I need to do is I need to come back and in my components folder, I need to create a component for Redis, which will be PubSub dot instead of RabbitMQ, it will be Redis, and I need to provide the Redis metadata here. How would I connect to the Redis cluster or Redis instance or Redis server, and what are the other metadata associated with Redis? And then without making any change to my producer or consumer, as long as that name is same. So if you look at the PubSub name and the topic name that we are using, as long as those names remain the same, Dapr would be able to publish events or messages onto Redis without a single line of code change in the application. That is the advantage we get by using Dapr. And this is not just for PubSub. This applies to all the other components like State Store. If we are deploying our application to Microsoft Azure and AWS, we can have two different states defined in our components, one for Azure, one for AWS, and without making a single line of code change, just by providing the right configuration at the runtime, we can use Dapr to deploy the same application to multiple environments. So why do we use Dapr, or what is the benefit of using Dapr? We can use it for any language and any framework which supports the HTTP API calls or gRPC API calls. It provides various building blocks for the cloud and edge related deployments. It also supports multiple hosting environments. Today we saw how to use Dapr on a local development environment and how to integrate Dapr with RabbitMQ. In the later parts of the series, we will see how this same application using Dapr can be deployed to a Kubernetes environment on local as well as managed Kubernetes environments. We looked at .NET SDK for Dapr, but it also supports other languages like C++, Go, Java, Python, Rust, PHP. And in this series, I also intend to cover things around Go, Java, and Rust. So we will see that later in this later parts of this series, how to use those programming specific or language specific SDKs. When it comes to the framework, there is support for ASP.NET Core, which we saw in today's demo. In the subsequent ones, I will also show how to use Spring Boot with Dapr. If you are a Python developer, then there is support for Flask, and if on the JavaScript side, there is support for Express. And whatever we saw today was mainly focusing on the developer experience or developer joy kind of scenario. There is also support for operations. It is not just purely development. It also has support for telemetry by using things like OpenTelemetry. And there is support for tracing like Zipkin. So if I go back to the Docker desktop again, and we quickly look at the Zipkin part here, there is this port which is map 9411, and if I go to Zipkin, we can see the dependencies, and we can see how different applications or how different microservices are making calls to one another. In our case, we have only two services here. One is the producer, the other one is consumer. That's why it's showing only two. But in your application, if you have multiple microservices and all those are using Dapr as a way of communicating with one another, we would be able to see them here. So with that, I come to the end of this demo or end of this video. If you would like to have a look at the code that I showed, everything is published to the Cloud Native Ninja GitHub repository. The slides are also published to SlideShare and Speaker Deck. Along with this session, also the earlier session slides are available there. If you want to refer to any of these links or you want to know more about Dapr, you can go over to dapr.io. We specifically looked at RabbitMQ PubSub component, so you can also know more about that. I also demonstrated the .NET Minimal APIs feature, so you can know more about those using the link, and Cloud Events, which is a standard again for open specification related to handling of events. So you can know more about Cloud Events. That is the end of today's session. If you would like to know more about Cloud Native application development, I've done various other videos, and there was one which was around 15 factor apps, which talks about what are the different factors required for building modern cloud native applications. You can have a look at that while we work on the rest of the series. Thanks for watching this video. Until next time, code with passion and strive for excellence.